Hello everyone and welcome. So in this short video that I'm sharing with you today, we are going to be solving two really simple LeetCode problems, and the point being that they have their solutions are related, and I just want to show you how simple it is to solve these problems in APL. And so the first problem we are taking a look at is 1480 running sum of 1D array, and basically what they have is they're going to give us a list of numbers, and we need to compute the partial sums over that list. So there's the example here. For the list 1, 2, 3, 4, we need to return a list with 1, 1 plus 2, 1 plus 2 plus 3, and 1 plus 2 plus 3 plus 4. And that's the running sum. So the partial results of summing the whole list. And this is really simple to solve in APL, because if we have a list 1, 2, 3, 4, then we can, well, obviously we could sum all these numbers together and that gives us 10. But APL provides this really useful operator, which is the reduce operator, that takes a function on the left and then sums everything together. And what's great about this is that reduce has its cousin operator, which is scan, and so this can be read as plus scan. And what scan does is it computes basically the same thing as the reduction, but also gives you the partial results. So this gives you exactly what we need. So notice here 1, 3, 6, 10, and that's what we have here in this example. Or if we want to take a look at this, 3, 1, 2, 10, 1. So 3, 1, 2, 10, 1, I think. Yeah, and now if we do plus scan, we get 3, 4, 6, 16, 17. 3, 4, 6, 16, 17. So this is it, just two characters of APL code, plus scan. And then if we take a look at this other problem I have in here, so the problem number 1672, richest customer wealth, what we have here is a grid containing money that different people have in their bank accounts. So this is the money the first person has in each of 3 banks, and this is the money the second person has in each of 3 banks, and we need to figure out what's the person that has more money. And this is a very simple example. So both of these persons have $6 or euros or whatever, and so the maximum number there is 6. And this represents, for example, the money that 3 different people have. And in here, we can see that the second person has 10. So we need to be able to sum these sublists and then add them and find the maximum value. And this is also really simple to solve in APL, because this two-dimensional grid, we can even see here it's indexed with 2 indices. This is a matrix, essentially. And so what we can do is, for example, with this one, so 1, 5, 7, 3, 3, 5. So we have 1, 5, 7, 3, and then 3, 5. So these are the 3 lists inside a big list. And what we can do is we can stack them up. Now we have a matrix, and notice that I can ask for the shape of this using the row primitive. And so what's the shape? It's 3, 2, meaning there's 3 rows and each row has 2 columns. And so if I take a look again at the plus reduction, if I use the plus reduction on this matrix, so remember that this is the matrix because this primitive here called mix is stacking the rows up, so plus reduction will sum along the rows. So let's take a look again. This is the matrix. Notice 1 plus 5 gives me 6, 7 plus 3 gives me 10, and 3 plus 5 gives me 8. So plus reduction, when applied to a matrix, sums along the rows. And then what we can do is, or what we need to do is, figure out the largest value in here. And APL has a primitive to compute the maximum of 2 numbers, which is this symbol over here. For example, 10 and 8 gives me 10, and also 8 and Okay, sorry for that. So 8 and 10 gives me 10, because 10 is the maximum value. And so I can use another reduction, because essentially what I want to do is take these numbers and insert a maximum in between all of them. And when we have a vector of numbers, that's basically what the reduction does. So this behaves exactly like I need it to. And so we can basically take the plus reduction and then do a maximum reduction. So that's, if we take our original matrix, that's the maximum reduction of the plus reduction. And that's it. This is our solution. If we want to write this as a function, we can say, well, the solution is the maximum reduction of the plus reduction of the mixing of the arguments. And this omega here is the reference to the argument of this little function. So there's our solution. And so when we have a list of bank accounts of different people, we can just do this. And that's it. This is 5 characters, assuming we have to receive this list of lists. If we were able to take the matrix as input, so if the input was actually the matrix, like it looks, well, it looks like it should be. So if this is our input, we can get away with just 4 symbols. So yeah, I hope this shows you a little bit of how powerful APL can be, even when you're solving problems like this. So see you in the next video.